September marks the peak of the Atlantic hurricane season, which extends from June through November. That uncertain time of year where we await the next big storm to see where it will make landfall and, what everyone really wants to know, what they will name it. But while we wait, let's take a minute to consider why we even have a season for hurricanes in the first place. So in order to understand why we have a hurricane season, let's build a hurricane. The perfect hurricane recipe calls for precursor storms, warm waters, and low wind shear. Let's start with precursor storms. Hurricanes build from smaller, what are called precursor storms. Start with a small disturbance or a thunderstorm, add warm water and wind, which we'll get to in a second, to build the storm bigger and bigger and bigger, until it becomes a hurricane, aka tropical cyclone, with sustained winds of 74 miles per hour or more, which is basically like putting your head out the window on the highway. Now in the Atlantic area, these precursor storms sweep in from Africa in what are called easterly or tropic waves, basically bands of thunderstorms that move west across the tropics. These are our precursor storms. Another ingredient in the hurricane recipe is a warm ocean. As air flows over the ocean, it transfers heat and water vapor up into the atmosphere. Through a cycle of evaporation and condensation, the warm, wet air builds clouds and creates updrafts. This warm, wet air acts as fuel. Add more fuel to the fire, so to speak, and you build a stronger hurricane. Hurricanes gain strength by forming high into the atmosphere. And in order to form high into the atmosphere needs to be somewhat calm, not too windy up high, not too windy down low. If one or the other changes, the hurricane can basically topple over and fizzle out. So we need low wind shear, which means there's little difference between the wind in the high versus low atmosphere. Our hurricane stays standing and its circulation is not disrupted by strong winds. So now that we know what hurricanes are made of, let's look at why they only form in the Atlantic during the summer to fall months. And to do that, we have to look once again at our basic hurricane ingredients. Remember those precursor storms blowing in from Africa? Well, those easterly waves form around summer and fall and peak in September. But due to factors involving temperatures and some other atmosphere science we won't get into right now, in our winter, all is quiet on that eastern front, and there are no real disturbances waiting in the wings. And winter in the northern hemisphere means cooler ocean waters. Cool waters means no fuel, means no hurricanes. And finally, in the winter months, the jet stream, which had been farther north during summer, shifts back down south, where it creates high wind shear right smack dab in the prime area for hurricane formation. With all of these factors in play, the winter months of the Atlantic region are hurricane-free, and we should consider ourselves lucky. In other areas of the world where ocean water is warm year-round and wind shear is weak, tropical cyclones can occur all year long. And that begs another question. With the climate warming and all, will the Atlantic hurricane season expand? And scientists have determined that that's a real possibility. But for now, we'll have to hold our breath until the hurricane season comes to a close and hope that this year we don't make it all the way to Wanda or Walter or Whitney.